All right, good morning. So we're going to try a test of hypothesis, one-sided this time. Okay, so I wrote out a problem for us. We have the mean pH level of the rain in a specific county in 1990 was established to be 5.03. That's kind of acidic. A scientist wonders if the rain has become more acidic. Okay, that means the pH level is going to fall in the year 2020. So it says, note that more acidic would mean the pH value is a lower number than 5.03. Okay, we are given this table of data. It has 19 values on it, and you said sort this out. So it is given. Problem gives us a couple of different things. Problem tells us that the rain is normally distributed and does not contain any outliers. We are also given that the standard deviation is known to be 0.2, and we are to test to see if the pH level is lower if the alpha equals 0.01 level of significance. Okay, so they have to include a couple of these things in order for us to do the problem. The reason why they told us it's normally distributed was because we only have 19 values. That is well short of the 30 required from central limit theorem. But since we know that it's normal, we know that any distribution, any amount that's coming out of that is also normal. Okay, and doesn't contain any outliers is a nice thing to have as well. Okay, so we're just going to go through our steps to see what's going on. Again, I'm going to do this with calculator in two different ways, and we'll see how we can do this. Okay, so we're going to go ahead and set up our test of hypothesis. Okay, or H1 rather. In this case, we are wondering if the pH is lower than 5.03. So we're going to say mu is either equal to 5.03 or greater than 5.3. And what we're trying to find, mu is less than 5.03. Okay, and again, I'm going to make my alpha 0.01. Okay, and I'm just going to write that at the top of the problem as we're working through it. Okay, so that's steps 1 and step 2. Okay, step 3 is we're going to calculate our test statistic. Okay, so again, sigma is known. We expect to use z. We've already demonstrated, we've already talked about the fact that this mean is going to be normal, and z is equal to x bar minus mu divided by sigma over the square root of n. And off to the side, I'm going to say x bar, right? That's the average. We don't know that just yet. I'll show you that in a minute. Mu is equal to 0.05. Standard deviation was 0.2, 0.2. And we have 19 values here. Okay, so I have almost everything I need here except for this x bar. And in the interest of time, what I did for us was I put this in the stat, right, and edit. And if you look in list 2, 5.08, and that's what's going on here. So 5.08, 4.78, dot, 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 dot. I put this all in list 2 so that I would have it. We're going to go back to stat. We're going to go to calculate, one variable statistics, right, on list 2, okay, and we're going to call that good. Okay, so my x bar here was 4.8105 or 4.81. Okay, so we're going to call this 4.81. All right, so let me put this together for us. Okay, we have x bar is 4.81 minus 5.03 divided by the standard deviation, right? That's 0.2 over the square root of 19. Okay, that's my z. So again, doing this by calculator, I'm going to go ahead and show you all the dirty stuff with this. So we're going to say this is going to be, right, what was that? That was 4.81 minus 5.03 and parentheses divided by 0.2 divided by the square root of 19, and we're going to get a z value of negative 4.79. Okay, this was negative 4.794, 4.79. Okay, so what we're looking at, okay, is here's my normal distribution. Since it's the lower part of the curve, right, negative 4.79, what I'm interested in is finding this value way down here. This is negative 4.79. So we're going to go back to our calculators. We're going to go to distributions. We're going to say normal CDF. And here I need a small value because the small value is like way over here somewhere. Okay. How about we try negative 100? All right. My upper value, negative 4.79. And this is a standard normal distribution. So I want 0 for the mean, standard deviation 1. Okay. So this is where we're calculating our p-value. Okay. And we get some absurdly small number here. It's 8.35 times 10 to the negative 7th. Okay, so the area here, the probability here, right, this is 8.35 times 10 to the negative 7th. That's a very, very small number. Okay, let me see if I can't, that might work a little better. Okay, it's a very, very small number that we have there. All right. Because this is a one-sided test, I don't need to worry about the other side. In the first example, right, we had two-sided, so we had to worry about positive side and negative side. In this case, we have one-sided. We just worry about the negative side, and that's it. Okay, so we have to look at this and say, okay, well, is 8.35 times 10 to the negative 7th a bigger number or smaller number than 0.01? This number, we have to go through seven zeros here. So 1, 2, 3, 4, 5, 6, 835 versus 0.01. Okay, that's the comparison we're making. Which one of these is bigger? Well, clearly, right, that's bigger. So since our p-value, right, is smaller than alpha, okay, we're saying that this is a very, very small probability of this happening just by random chance. So since it's not going to happen by random chance, that's our threshold for random chance, we're going to say that we should reject the null hypothesis, reject HO. The rain has gotten more acidic. The pH has fallen. The pH is lower in 2020 than, did I tell you when this was started? 1990. Okay, then in 1990, or the rain is more acidic now than in 1990. Okay, that would be just fine. Okay, well, that's how you do this thing with a calculator the long way, but fortunately, your calculator will actually do this quicker. So let's go ahead and look at how that goes. Now, these first three steps, right? Step 1, setup. There's it go. Now we're in frame. Step 1, set up our hypotheses. Step 2, declare our alpha or level of significance. And remember, in statistics, significance does not mean important, right, like it does in English. It means noticeable, okay? So this is the noticeable effect. It doesn't mean that it has to be important. It's just that we can tell there's an effect here, okay? So don't let somebody bully you with this word's statistically significant. It just means noticeable. Okay, I always like going back to the Princess and the Pea fable. For the princess, the pea was noticeable. For some of you who may go camping, if you ended up having like a shovel full of gravel in your sleeping bag, that may not be significant. Okay, you may not notice the gravel. Okay, so let's take a look at setting this up. Oh, let me finish my thought there. Calculate the test statistic, figure out the p. This was step 4. And then step 5 was we made our conclusion, and notice that we came up with a sentence saying what was going on here. Okay, so we don't have to like just let somebody go, oh, we rejected the null hypothesis. Off you go. Like, no, tell them what's going on here. All right, so let's have a look at how would you do this in the calculator. So step 1 and step 2 are going to be exactly the same. Step 3, what you're going to do here is, again, we're going to go to the calculator. Let's see here if I can get a little bit more light. That looks a little better. Okay. We're going to go to, notice again, right, I went to stat, edit. My list 2 here has the values that were in the problem, so we're all set up here. So we're going to go to stat. I'm going to go to tests, And again, we're going to pick that first one. It's a z-test. That's the one that we're working with. It says enter. And in this case, instead of stats, instead of entering the values myself, okay, I'm going to go ahead and say data. Okay, that's the data. My mu was 5.03, so we have to change that a little bit. Okay. The standard deviation was 0.2, not 2. Okay. It already fills this in for us. It filled in that my x bar was 4.81. You don't have to do that. You told it. You don't have to fill in that n is 19. We told it. Okay. Now we do have to tell it what kind of test we're doing, and we're doing a less than, right? We're doing a one-sided test where it's less than, right? And then we'll go ahead and say calculate. Okay, so what you would type in for your step 3 here, okay, we went to z-test, all right, and then we gave it stats. We said mu0 was 5.03. We said sigma was 0.2. We said x bar, because it automatically generates this for you, and is equal to 19. And we want mu is less than mu naught. Okay, that's how your calculator does. And then we're going to get an answer. Okay, so I want you to tell me like what you're typing in the calculator so I can follow along with you. But we'll go ahead and say calculate, and look what it gives us. Oh, wait a minute, we didn't do it right. We got a 9 equals 2. So let's go back and double check that. So stat test, go through, boom, 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 and we want the less than one. That's the one we want. Okay, and now we're going to calculate. Okay, so we have mu is less than 5.03. That's what we set up. Our z was negative 4.78. That's what we got with the other problem that we did. We got 4.79, but it was a round off error. Our p-value, right, we got very similar. Instead of 8.35 times 10 to the negative 7, we got 8.63 times 10 to the negative 7. That's not a big deal, but we still got an effective, right, we still got effectively the same p-score, p-value as we got for the other one. So in the same idea here, we'd say p-value, right, is equal to 4.81 times 10 to the negative 7, or 4.63 rather, 4.63 times 10 to the negative 7th. Okay, and since my p-value, right, is smaller than my alpha, that's the cutoff, right? This is much, much smaller than that. If it was bigger, then we'd say don't reject HL. But since it's much, much smaller, we say reject the null hypothesis, okay? And going back, if you ever wonder, it's like, where am I in the problem? What am I doing? What did the null hypothesis say? The null hypothesis said that the average was equal to 5.03. We rejected this. So what's the alternative? The alternative, it's less than. Okay, so reject the null hypothesis. Mu is smaller than 5.03. Okay, the rain has become more, how about just more acidic over, 3 decades. Okay, so again, tell the person that's reading this something about what your conclusion is. You still want to say this as kind of having a place to work from, but it's really important that you do that. All right, so I'm going to go ahead and post these guys tonight and let you get started on something and go practice, and I hope this helped. All right, thanks, goodbye.